All right, all right. Hey, everybody. Thank you all for joining today's talk. Um, Hope you all are enjoying the conference so far and you guys have gotten a chance to eat some lunch. If not, um, try not to fall asleep during this talk and you can grab something afterwards. But my name is Justin Moss. I'm one of the engineers for Axonius, and today's presentation will be focusing on shrinking the attack surface. And I think one of the best ways to get into discussing the attack surface is to start us off with a quote. So this quote focuses on, or says, winners don't just learn the fundamentals, they master them. And whenever it comes to the fundamentals, you really want to get into what are we trying to focus on here and how does this relate to cybersecurity? Who came up with this quote in the first place? It's actually Michael Jordan. And I think that first, he's one of my favorite players and greatest of all time. And I think he's done a really good job of, in the professional sports space, doing a really good job of mastering the fundamentals. So therefore, even in the face of adversity, noise, or all kinds of different distractions, he's sticking to the fundamentals, which is a core component to his level of success that he's been able to have throughout his career. So moving on, how that is relating to cybersecurity, whenever it comes to shrinking the overall attack surface, the best way to do so is, again, to master your fundamentals. And that just means that understanding your attack surface, your asset management, and most importantly, how do we assess what we have in place? And it kind of leads us right over to this next screen here. Without mastering the fundamentals, you can end up on a poster, or you can end up an organization or a victim of attacks like this. One of them being back in 2015, one of the largest breaches that took place around that time was for OPM. It hit over 21 million people. And the reason why this was so large for just the world and a lot of government entities is because this is a government organization, and the OPM is the Office of Personnel Management, and I was actually affected by this piece right here. Whenever it comes to just having that attack surface being attacked, I had a background check that had took place a couple of years back, and I had some of my references that were part of this process as well, and some of our information got leaked, and even following this process here, like I had someone try to file taxes under my name for about 2 years in a row. So that was a fun process, and now every time I go to file taxes, I have to do all kinds of jumps and hoops and a little dance just to make sure that I can confirm that it's me. But another really big attack was in this piece back in 2021, where we had the Colonial Pipeline compromise that took place. So we all know that this was a pretty big one that hit us, primarily because it's focusing on the critical infrastructure. And we all know that the country runs and is maintained to be a happy place because of our ability to have gas and oil, electricity, water, all that good stuff. And these are examples of breaches that have taken place because of leaked credentials. Once more, some organizations, rather it be an asset or multiple assets that were maybe not identified at the time, but again, allowed some level of initial access to the environment to cause some level of attack. So the goal here is how do we master our fundamentals, which is shrinking the attack surface so we don't end up on a poster, either as an organization or as an entity alone. So we can get into this by focusing on the agenda for today. We'll be breaking down the attack surface 101, what that means to the crowd, and we'll get into how we can assess the attack surface. And then the rest of the talk will really be focusing on what can we do to actually shrink our overall attack surface as well, getting into the discovery piece, which is sometimes one of the hardest parts of shrinking any attack surface, is just understanding what we have, getting into the context. What does it look like to dive deeper into the data once we've been able to identify what we have, and then be able to prioritize that. There's a lot of devices out there, there's a lot of data that exists, but what data is going to be most important for us to be able to dive deeper into whenever it comes to shrinking the attack surface? We can't just shrink everything. We got to focus on what's going to maximize, give us the least or take away the most amount of risk with the least amount of effort. And then we'll get into the remediation portion, what that looks like and how you can take action with shrinking your attack surface and what options you may have from this perspective as well. So looking at the attack surface one-on-one, before I even move forward and talk about what this means to us or how we see it, if anyone in the crowd wants to just either blurt out a quick sentence or maybe even just throw out their own idea of what the attack surface means to them, I'm open to taking some input. Anything that can be exploited, 100%, that's right. He said he automatically thinks of USB ports. Yes, that is definitely, as a matter of fact, I think I may see a little thumb drive hanging around here somewhere. Someone don't pick that up. But yes, this is exactly it. Our attack surface are the things that, the entry points to our environment, right? And the things that are going to be able to, cause some level of maybe not risk, but connection to what we have as our devices. So to continue on with that idea, when we talk about the attack surface in a traditional sense, we had our endpoints, our servers. We're going back maybe 25, 20 plus years ago, which was our traditional perimeter, and our internal environment as well. There weren't many devices for us to have to manage. It was much easier for us to, leverage or manage our endpoints and our servers through our typical MDM solutions, and maybe a spreadsheet or here or there, WSUS to update patches. But as we continue to grow from an organizational perspective, and also as the technology has also increased for us as well for access for productivity of tools, you've got some of the more modern tools. You've got mobile devices. You now have to focus on the identity of users and the permissions that comes with as well for those devices. We've got new applications, new websites. So this also incurs, if we have a dev team, what does that development lifecycle look like in terms of management from that perspective? If we have a BYOD policy, or in our modern time now where we have everybody coming in and out of the office, how are we able to identify and discover those IoT devices while also managing these users? This is our modern perimeter now that we're looking at. And then we get into some of the expanding perimeter, once more getting into where we are today, where we have our digital supply chain or our IoT devices, social media. That's going to be a big piece where that kind of information, once more, if we're not taking care of how we're locking down our credentials from that perspective, those pieces of information can either be impersonated, and we would be, representing the organization in a not appropriate way, right? From an attacker's perspective, to go ahead and gain some initial foothold. Certificates, even talking about SaaS, we're looking at SaaS applications. So you've got your managed applications, your unmanaged applications from a shadow IT perspective. When we look at even our devices today, we have a lot of applications that we have access to. And the big question is, how do we manage that piece? How do we understand that? But first and foremost, what's going to be most important so we can prioritize and we can shrink what we have overall. So when we get into the analysis of the attack surface here, kind of piggybacking off of what we called out before in terms of our nouns, or not of our nouns, but our definitions. The attack surface in our eyes is all entry points to your assets, like we called out before, right? So anything that has, an opportunity to connect, or an an endpoint, or maybe it's a server, or maybe it's a device, or IoT device, or whatever you may have it. If it has access to your assets, that's some kind of a attack surface. Those devices are attack surface devices, and we'd be able to track those things and see what we can do about minimizing that surface for you guys. So how do we assess the overall attack surface? Step one of the things we like to note is assessing your entry points to your assets. We talked about this piece being probably one of the toughest parts of the journey, because how do we assess our assets? What do we deem as an asset? Is it just our workstations, our physical devices? Is it going to be our digital assets as well? And then step two is getting into the assessment of the code that protects said entry points as well. So This is getting a bit more specific into the data. Um, yes, it's important for us to be able to understand our assets, but what's really going on those assets? What kind of level of access or code is that endpoint or that workstation posing on itself to be able to be deemed as something that's worth us even protecting in the first place? Is it something that should be considered an entry point based on the level of code or data that exists on that tool? Step three is being able to assess the sensitivity of that data that that asset uses. So step three, in addition to step one and two, is all in conjunction. Once more, understand our assets, the code, but really, what's the level of sensitivity that that data is going to bring to me as an entity and also me as an organization? If we can understand that level of sensitivity, that's really going to be able to assist our prioritization efforts to move forward from that perspective there. And then we have step four, where we're assessing the code that protects the data. Step one through three is an iterative process, and then you get down to step four, and we're really kind of repeating that, the steps for assessment, but really just focusing on the core component, where's the code exists, what's going to be protecting our environment, and how can we be sure that whatever repository that's pushing out said code and is giving it, is being accessed by these different devices, can we assess that piece and make sure that that's being run smoothly to ensure that we're not putting ourselves at any risk for any supply chain attacks? And how we, to continue on with the assessment of your attack surface, some things we can do is break things down by business and also use case. So what we're typically seeing out in the field, whenever we're trying to assess our environment, we're looking to build our asset inventory. That's a typical business case we're getting from our clients, rather from a strategic perspective. It's something that's being pulled in either by strategic stakeholders or maybe from a compliance perspective as well. And the overall use case from a technological perspective is, how do we display all of our asset inventory technologies essentially? What does that look like for us? Our goal is to be able to build a credible asset inventory. We know with most of our frameworks we're having to adhere to that. Control 1, Control 2, and most frameworks are asking for that. But how do we do that from a use case perspective? And that's where we get into the technological piece to be able to gather all those devices there. The next thing is monitoring agents deployed on your production assets. So now we're getting into, once more, the risk implications of your attack surface. These are monitoring those agents deployed from a production perspective gives us an opportunity to see where we have potential gaps. And that's where we can see in the use case section, we can find endpoints that are missing your agents, right? From that perspective, being able to track down those endpoints that are missing your agents with the technology that allows you to do so can drastically reduce your overall attack surface, because you understand, from a security control perspective, where those gaps exist and how we'd be able to drill that piece down. Another pretty hard thing to do, but really important process for us to track on from a business perspective, is ensuring 90% vulnerability scanner coverage. Not just being able to assess the vulnerabilities, but at least just saying that we have 90% coverage across the board, to say that these devices, these assets have at least been being seen, right? And they're being tracked by our vulnerability management solution. So the technical use case being, can we find those devices not being scanned by that vulnerability scanner? I'm not sure if anyone else here has dealt with this. I've had a handful of experience, working with vulnerability management programs and also program builders. And that's probably one of the hardest things for us to do, is kind of solidify our overall vuln management, process, especially whenever it comes to just not knowing where our devices is or where we want to look for, especially whenever we're talking about the limitations sometimes from a scanning perspective. And then the last thing I'll call out here is the business case for scan production application code for vulnerabilities, and then the use case being vulnerable scan application code. So we're kind of getting into that, more of that application security side of the house, right? Where we can get into some security code analysis, or maybe we're leveraging a WAF or a web application firewall, or a DAST solution, like a dynamic application security tool, where we can really assess the code of said applications from an OWASP perspective, and be able to break those things down and see what our websites our hosting and how we can minimize, once more, the attack surface around vulnerabilities for those websites, rather production or in QA, or ready for production, so we can minimize from that perspective as well. So now getting into the overall discovery piece, we understand that these things are important around assessment, but once more, how are we looking to discover information within the environment? And I'm breaking out one of our examples from one of our platforms within Axonius. We have 2 products. One of them focuses on our SaaS management. And when I say SaaS management, I'm really focusing on the use or the visibility of data sprawl for your SaaS applications. So we all have, or we may have, an IDP or an identity provider, our typical solution that's going to help roll out our approved software for application usage for our users. And then we also have things like Google Workspace or Microsoft or Salesforce, whatever it may be, where we're enabling our users to access internal resources through these pieces. But we're also saying that those same application integrations have their own marketplace where the user can download their own productivity applications like Calendly or Grammarly, right? And these may be fourth-party applications that you may not have, given access to, but the user via their workspace marketplace area in Google Workspace have access to. So we're trying to break down, again, discovery. How can we minimize the attack surface? But you can only do that by first knowing what you have. And just looking at my computer alone, or anyone else's, laptop, I'm pretty sure there's a lot of application that you guys have access to. And just imagine walking into like this space right here, being able to see, one, what's managed, what's not managed, but most importantly, how can we go ahead and shrink that piece? That's what we're trying to focus on from this perspective. So getting over to the protecting your attack surface, this is where we're looking at our cyber asset and attack surface management coin. This piece right here wasn't coined by Axonius. It was actually the name was given to everybody in this space for asset management by Gartner and the Gartner hype cycle about 2 years ago, or about a year ago, actually. And Chasm, as it's pronounced, is focused on asset visibility and vulnerability changes. So it's a tool or a set of tools that can help you gain visibility into your assets, but most importantly, let's understand the delta change. We see our devices that exist within the organization, but let's go ahead and track the change over time so we can assist our vulnerability management program and also our patch management process there as well. And then we can also break down what Chasm also focuses on is leveraging tools that can show all of your assets from an API perspective or API integrations. One of the hardest things that we've seen across the board is being able to track our devices with antiquated processes. Maybe we have an agent, or maybe there's a scanner or some type of network span port or network sniffer. Those things work for us, and I say antiquated with air quotes around that because it's what we're all used to. But there are some other tools that are giving us less bandwidth utilization across the board, but also giving us the same level of fidelity, if not better, in terms of identifying what devices exist on the environment without having to cause increased deployment times and prolonged discovery cycles, and potentially knocking down our devices from some of those more traditional forms of discovery. And then the Chasm solutions are also focusing on giving you a consolidated, query form, or more so after you've been able to discover your assets, through a lightweight formality from a deployment perspective. What can we do to correlate that information? One of the challenges we typically have in our space is, identifying our devices, but how do we have confidence in the fidelity of duplication or just the level of information that may not be accurate from some of our tools? We all know if we're doing a scanner, we're leveraging a vulnerability scanner. If it's not an authenticated scan, we may not be getting all the full details of that. So we're looking to cross-reference that information with other tools to help us increase the fidelity of not just one device across one source, but one device across multiple sources to increase the fidelity of how many devices actually exist, and then can also improve our decision-making whenever it comes to understanding what our attack surface is, and then taking action on our next steps of shrinking that piece as well. So this is a quick little graph I've implemented within the presentation as well, just to kind of show where Chasm is on the hype cycle. Very, very, very early stages here. We see it at the almost the bottom left-hand corner. So it's the very early stages of the hype. We can see on the farthest right-hand side, we have things like NDR or our web application firewall tools, DDoS defense, right? These are things that are pretty much have been around for a good amount of time and have proven their value. But like we called out before, there are new ways for us to be able to identify our devices. So therefore, we can take action on shrinking our attack surface with a way that's going to cause the least amount of bandwidth utilization, and also reduce the most amount of risk in any way that it can. So now we're going to move over to the context piece, and I brought together this this little infographic just because it's kind of bringing back PTSD in some areas where I've worked with CMDBs and I work with some in-house SQL databases here in spreadsheets where you're trying to focus on or identify one device. I'm looking at the host name here. We can see the host name is relatively the same, but we can look at the data source column and we see from Active Directory all the way down to Forescout, depending on how the data is being collected, some information is going to be available to us. Some of it is not going to be available to us. So it kind of goes back to that idea of how do I know what I'm looking at here is one device? Is it duplicated? Information is not the same. How do we go about consolidating that information, right? If we're leveraging our traditional means, maybe through a spreadsheet, this can be a manual process. And we can it can lead to more questions like this, like, are my agents deployed everywhere they need to be, right? This is one device, but am I saying multiple devices? What's the case there? Are my critical resources accessible by the public? So these are questions that we can ask of tools that give you visibility of said device, and also allow you to cross-reference that device's access to different management tools. Maybe it's a networking solution, and you'd be able to quickly identify, is it a public accessible IP? Is it going to be something that can be accessed only internally? And how do we slice and dice and minimize that risk just from being able to get that level of visibility there? And then we can also understand which critical vulnerabilities exist within my assets, right? Rather it's OS type from end of life cycle from that perspective, or just tracking those vulnerabilities on the CVE side. So then we can get over to the prioritize section, and this is bringing back that list that we talked about before. It's important to call these things out. We have the business case, the use cases from a technological perspective, but when we're looking to prioritize, it's good to know what we're looking to assess. But what we really want to focus on is the level of severity that we can assign to the things we've assessed within our environment here. So are we looking to add a level of criticality or high meter or low or medium to these things that we've been able to assess? And that's going to, once we've got that piece in place, allow us to once more use the least amount of effort, but reduce the most amount of risk within our environment from that perspective there. So then we can move on to the remediate piece. And this part right here is really is bringing back what we had seen before, but just calling out just some additional points, like being able to notify if an asset is being scanned by a vulnerability scanner. These are some of the actions that we can take within tools that are, one, helping you see all your devices, and then two, asking the intelligent or the harder questions from a security perspective. Now that you can see everything that you have, but now we can go ahead and take action on some of those gaps we may have identified for this device. Maybe it was not seen by the last scan cycle for your vulnerability management solution, or it doesn't have an agent. So we can identify that really quickly, leveraging the correlation across APIs and a discovery tool that's going to present everything to you in the central system of record, and then you can take action by adding that device to the next scan schedule or adding an agent to that. You can also notify someone if that asset is publicly accessible. Maybe we are identifying some of our users, maybe on the dev side, who are creating entities, or not even entities, but more so these from a co-repository perspective or an application, and they're not following change management processes appropriately. If you're able to identify if you have a cloud migration environment and you have workloads in the cloud, you'd be able to quickly identify what devices are labeled as a workload in the cloud for AWS, GCP, whatever it may be, which ones are publicly accessible, who is actually managing and releasing this image here, or who's in control of that, who last touched it, and what can we do to go ahead and put this on the right segment to minimize risk from that perspective. And then we'd also be able to notify you guys if any assets have any critical vulnerabilities. Once more, focusing on, what's even from a Node.js perspective, what do these things look like? We have, or Log4j, apologies, Log4j. Which of these devices have Log4j deployed onto them? What's the overall version? How can we go ahead and identify the CVEs that exist and then minimize from that perspective too? So, wanted to kind of wrap through that pretty quickly, but I'm going to leave room for any Q&A. Again, today's talk was really focused on shrinking the attack surface from being able to assess and then get into our ability to perform said actions around discovery, context prioritization, and then also remediate. So I'll leave the room open for any questions here, and we can wrap things up. All right, all right. Silence is compliance. All right, team. I'll let you guys get back to it. Thanks for taking the time to spend some time with me today.